Chapter 8, Kinetic Theory of Gases. From this chapter, we'll get an idea about how that particle that will lies in a gas. As we know it very well, all the substance made up of like molecules, atoms, as well as ions. If we think about solid, so intermolecular distance is very, very less, and all the molecules are tightly bound. If we think about a liquid, comparatively less bound, and in the case of a gas, there are random motion of particles, random motion of molecules. So here we will dealing with the pressure, volume, as well as temperature, as well as in a kinetic energy terms. So kinetic theory of gases basically give idea about how that pressure changes, how that volume changes, how change in the temperature take place, as well as how that internal energy of that gas changes. So now, as we just think about, first of all, in that introduction, that as they mention here, that any physical form of matter, it's made up of like atoms, molecules, or ions, which are considered in a continuous motion. So if we just think about the solid, the study of behavior of gases in terms of constituent particles, very easy and situated, which is studied in a kinetic theory of gases. As we discussed just earlier, if we think about the solid, liquid, as well as gases, in the solid that particles are very, very close to each other. If we think about the liquid, comparatively less close, and in the case of a gas, they have the random motion. So here we are going to study about that kinetic theory of that gases, how they behaves when if we provide that kinetic energy to that gas molecules. Here they also mention that kinetic theory of gases is based on the gas laws and on Avogadro's hypothesis. I think the similar topics you have studied in chemistry part, like kinetic, that's gas laws, as well as Avogadro number. I think Avogadro hypothesis, तो आपको Avogadro number और जो laws है उसके बारे में शायद आपको पता हो सकता है, because it's a common topic in physics as well as in chemistry. Now here, first of all, it shows that physical quantities like pressure, temperature, volume, internal energy are associated with the gas. So basically here they just try to explain there are two types of quantity. One is a microscopic quantity, another is a macroscopic. Macroscopic quantity means what? From the name, micro as well as macro. Micro means which is a very, very small, macro means a little bit bigger. So whenever we just discuss like the pressure, temperature, volume, as well as internal energy, which is associated with the gas. So here we have to study that pressure, temperature, how that microscopically change take place in the system. मतलब कोई गैसियस सिस्टम है जिसके अंदर हम धीरे धीरे प्रेशर बढ़ा रहा है. मीन्स इफ वी ऑब्जर्व, इफ वी स्टडी एट माइक्रोस्कोपिक लेवल, तो यहाँ पे ये जो क्वांटिटी दी गई है जहाँ पे बड़ा सा डिफरेंस हमें देखने को मिलता है, लाइक प्रेशर एज वेल एज टेम्परेचर एज वेल एज वॉल्यूम एज वेल एज इंटरनल एनर्जी. यहाँ पे हम जो भी ये प्रेशर, टेम्परेचर वगैरह वगैरह है, मे बी वी कैन मेजर इट डायरेक्टली और मे बी वी जस्ट ऑब्जर्व विथ है microscopic quantity. Like a pressure and temperature, we can measure it directly. But if you want to measure internal energy, we have to study how that pressure changes, and that pressure that gives a change in internal energy. Is that clear? Now here, they also explain these quantities are obtained as an average. Here you have obtained this quantity with the average combined effect of the processes. Obviously here you have to take that average. Why? Because gas molecules, that number of gas molecules as well as that volume, that pressure of that gas, you cannot get that exact value with the help of only one observation. So definitely here we have to take some more number of observations, and from that if you get the average combined effect that taking place at the microscopic level, मतलब बहुत बारीकाई से अगर हम उसको ऑब्जर्व करेंगे, माइक्रोस्कोपिक लेवल पे हम उसको स्टडी करेंगे, और दिस सिस्टम दैट इज नोन एज मैक्रोस्कोपिक क्वांटिटीज. तो सेम लाइक दैट, जैसे मैक्रोस्कोपिक आ रहा है उसी तरह से माइक्रोस्कोपिक क्वांटिटी भी आता होगा. और यहाँ पे ये जो पॉइंट बताया है, द डिस्क्रिप्शन ऑफ अ सिस्टम एंड इवेंट्स. So when there is a description about the system as well as event associated with it in the context to microscopic quantities, that is known as macroscopic quantities, that is known as macroscopic description. So same like that, if we have some quantity that's a microscopic quantity और उसका डिस्कशन होगा, उसको हम macroscopic description ऐसा हम कहेंगे. So here they mention the physical quantity like speed, momentum, kinetic energy and etc. that's associated with the constituent particles at microscopic level. तो यहाँ पे जो भी है पार्टिकल का स्पीड है या तो मोमेंटम है, जो भी उसको एकदम बारीकाई से एकदम उसको माइक्रो लेवल पे उसको ऑब्जर्व किया जाता है, माइक्रो लेवल पे स्टडी होता है. इसीलिए बिकॉज इफ यू जस्ट थिंक अबाउट वन कंटेनर, एक कंटेनर का कितना प्रेशर लग रहा है पता चल सकता है, कितना टेम्परेचर बढ़ाया वो भी आसानी से पता चल सकता है. बट इफ यू थिंक अबाउट दैट स्पीड ऑफ द पार्टिकल, दैट मोमेंटम ऑफ द पार्टिकल, दैट द काइनेटिक एनर्जी ऑफ द पार्टिकल, so it is very, very difficult. So as you observe, as you study at a very, very small scale, it means at the micro scale. So that microscopic level, microscopic level quantities, that is considered microscopic quantities. और उसका जो description होगा उसको आप कह सकते हो microscopic description. As simple as that. Is that clear? चलो. And now here that in this chapter we are going to study about that pressure, temperature and volume of the gases as well as other parameters like how viscosity, conduction, diffusion and specific heat. Let's change these parameters. Is that clear? Is that clear? But हम यहाँ पे ज्यादा फोकस करेंगे pressure, temperature और volume के relation पे in this topic. The topic is behavior of gases. How that gas behaves when if you keep one quantity constant and if you check relation with other two quantity out of pressure, volume as well as in a temperature. So that first law is a Boyle's law. तो Boyle's law को हम simple terms में ऐसा कह सकते हैं, Boyle. ओके, मान लो Boyle's, यहाँ पे Boyle's law जो है ऐसा आप याद रख सकते हो कि कोई भी चीज को बॉयल करने के लिए टेम्परेचर देना पड़ता है. So in the Boyle's law that temperature remains constant. थोड़ा आसान हो सकता है. Here it shows that at constant temperature, अभी जो ऐसे बताया कि बॉयल करने के लिए कोई भी चीज को बॉयल करने के लिए टेम्परेचर देना पड़ता है, तो ऐसे याद रख सकते हो. और यहाँ पे आप कह सकते हो at constant temperature and low enough density. It means if you take mass constant, because in the next line they mention low enough density, the pressure of a given quantity means mass of the gas is inversely proportional to its volume. तो उसका मतलब यहाँ पे ये होता है कि if you are going to take low enough density, density का मतलब होता है mass upon volume. So here if you are going to keep mass constant, it means you have to change that volume. तो यहाँ पे low enough density चाहिए. तो enough अगर density अगर लो रहेगा, वो तभी लो हो सकेगा जब प्रेशर है वो बढ़ेगा. So whenever we just think about the pressure increases, okay, so what's the relation with the temperature? तो यहाँ पे आप ऐसा कह सकते हो कि that gas is inversely proportional to its volume. Okay, so that the pressure of given quantity of gas inversely proportional to volume. तो यहाँ पे आप ऐसा कह सकते हो that P proportional to, that's a P proportional to 1 upon V. Okay, so here this graph is pressure, which is in atmospheric pressure, that's in upward direction. On the x-axis there is a volume, which is in liter. Here we have two types of graphs. One is experimental graph, other is a theoretical graph. So theoretical graph shows that pressure decreases as also volume decreases. Here, first point, this is the first graph for higher temperature, T1. Maybe it's a more slant or a more straight line. Here there's a T2 temperature, and third one, that is for T3 temperature. So here it shows that pressure is inversely proportional to volume, where the T1 is greater than T2 is greater than T3. So as the temperature value decreases, you will get that more and more slope curved part. So here it shows that at initial point, as volume is small, pressure is very, very high. As that pressure decreases, here as pressure decreases, that volume increases. That's a simple law here. This lines considered as a practical values, means experimental values. But if you think about the theoretical values, so that is approximate parallel. So if it's a parallel, so it's very, very difficult to find more true value for this graph. So here that T2 as well as T3, this dotted line considered as a theoretical value, as well as this dark line, straight line, okay, continuous line, that is considered as an experimental value. Is that clear? Sure.